Good morning to all. Today the name of the topic is Introduction to Database Management System, that is known as DBMS. So this is the first lecture, and in this lecture we will study about what is DBMS, why we use it, and how it helps to store the data, and what are the various outcomes of studying this subject. All will be discussed in this lecture. So name of the subject is Database Management System, that is known as DBMS. Now, we have some course outcomes that we will discuss one by one. The course outcome one is that you will understand the basic concept of DBMS. What is DBMS, where we can use it, what are the various models in the DBMS, what is normalization, what is data security, concurrency control, and all that. Second course outcome 2 is how can we formulate and we can use the SQL, that is structured query language, and the solutions to a broad range of query and data update problems. In this CO, we will study about SQL means how can we create a table, how can we insert the value in the table, updation of table, deletion of table, select query, different commands we have to study, like DDL command, DML command, TCL command, all these commands. Next is course outcome 3. Demonstrate an understanding of normalization theory and apply such knowledge to the normalization of database. In the topic of normalization, we have to study 5 normal forms: normal form 1, 2, then 3, then BCNF, then normal form 4th, then 5th. And in the course outcome 4, we will study about how can we understand the concept of transaction and query processing in DBMS. So we have the 4 outcomes of this course. So in this subject, first we need to understand what is DBMS and how it works. Then we will study about the SQL in the detail, and in SQL we have to study various SQL commands, cursors, triggers, functions, procedures. And after that, we will cover the topic of normalization. In normalization, we have to study various forms of normalization. How can we normalize the table, and how can we denormalize the normalized table? And at the end of this, we have to understand the concept of transaction and query processing. Next, have an overview of syllabus. In the unit 1, first we will study about the introduction of DBMS, means what is database management system, its characteristics, advantages, disadvantages. Second is data modeling for DBMS or database, like how many types of data models. 3-level architecture of DBMS. We have a 1-tier architecture, 2-tier architecture, and 3-tier architecture. The next is components of DBMS. What are the various components of DBMS? We will study in this topic. Next is introduction to data models. In DBMS, we have a hierarchical model, network model, relational model. Then we have to study about the comparison of a network, hierarchical, and relational model. And the last, we have a entity relationship model. So this is the syllabus of unit 1. Now we are going to discuss about some course outcomes. Course outcome means when we study about DBMS, what we have to learn. So course outcome 1 is that understand the basic concepts of DBMS. So in the course outcome 1, we will study what is DBMS, what are the various models that we have to use in the DBMS, what is the architecture of the DBMS, it is the 1-tier architecture, it is the 2-tier architecture, it is the 3-tier architecture. Tier means level, it's a level 1 architecture, level 2 architecture, or level 3 architecture. Then we have to study about the components of the DBMS, means like it consists of data, it consists of procedures, hardware, softwares. What are the various components that we are working in a DBMS? Next, we have a CO2. CO means course outcome. So course outcome 2 means formulate, and we will use the SQL, that is a structured query language. It is the language in which we have to do the commands. By using the SQL, we can create a table, we can update the table, we can delete a table, we can drop a table, we can truncate a table, and we are able to do some updations in the table. We can insert the values in the table. In the practical class, we will discuss everything in the detail. We have our commands in the SQL. In the course outcome 3, we have to understand about the normalization. Actually, normalization is one of the term in the database management system that is used to remove the duplicacy from the table. So normalization have forms: first normal form, second normal form, third normal form, DCNF, then we have a fourth normal form, and the last we have a fifth normal form. So all we will discuss about normalization in the CO3, that is course outcome 3. Next, we have a course outcome 4. This is the last course outcome of the DBMS. In this, we have to study and understand the concept of transactions and query processing in DBMS. What is transaction? What are the various types of transactions? Concurrency control, data security, integrity. All these topics should be covered in the CO4. Next, have a look on a syllabus. We have 4 units. In the unit 1, we have to study introduction of DBMS. That is, what is database management system? What are the various characteristics of database management system? What are its various advantages? What are its various disadvantages? Next, we have a data modeling for database or DBMS. Means what type of models we have to represent the data in the DBMS. We have a hierarchical model, network model, relational model. We have an entity relationship model, and we have to study about the comparison among all these models. Next, we have a 3-level architecture of DBMS. So first we will study about the 1-tier architecture, 2-tier architecture, and 3-tier architecture. Next, we have a components of DBMS. As I have already discussed, what is data, what is procedures, all these we have to discuss in the components of DBMS. So the syllabus of unit 1 is introduction, data models, architecture of DBMS, and various components of DBMS. Now come to the unit 2. In the unit 2, we have to study about relational database, relational algebra and calculus, SQL fundamentals, that we have to study about the various SQL commands, DDL, data definition language, DML, data manipulation language, DCL, data control language. Next, we have a PL SQL concepts. In this, we have to study about what is cursor, how can we create the cursor, how can we replace it. Next, we have to study about stored procedures, stored functions, and database triggers. So this is the syllabus of unit 2. Next is unit 3. It is completely about the introduction of normalization. Basically, normalization is one of the terms that we use in the DBMS to remove the duplicacy from the tables. So make it sure that tables should be good enough, like there will be no duplicate value in the table. All the values are unique, atomic values. So we have our first normal form, we have a second normal form, third normal form, and next we have a Boyce-Codd normal form that is known as BCNF. Multi-value dependencies we have to discuss, then fourth normal form, then we have a fifth normal form, then we have a DKNF, domain key normal form. So all these normal forms we have to study in the topic normalization. The last unit of the syllabus is unit 4, and in this unit we have to study about database recovery. Means how can we recover the lost data. Concurrency management means if two transactions want to get the same resources at the time, how can we protect and control it. Database security, it means how can we secure the data and how can we protect the data. So in unit 4, we have to study about database recovery. Recovery means how can we recover the lost or stolen data. We have different types of recovery techniques that we will cover in the database recovery topic. Then we have a concurrency management techniques, data security. It means how can we protect the data, integrity and control. Integrity and control means how can we ensure atomic and unique values in the database. Then we have to study about the structure of distributed database. And how can we design the distributed database? Distributed database means there is a one central server and have the different workstations. That was all about the introduction of the syllabus. Database management system. So database management system is a software which is used to manage the database. Basically, database management system, it is one of the system that is used to manage database. Means it is used to manage the tables we have created. It is used to manage the updations that we have done. So all the database management is done by one term that is known as database management system. For example, we have various types of database management system, like we have a MySQL, we have a Oracle. These are the very popular softwares that we use for database management systems. DBMS, that is known as database management system. It provides an interface to perform the various operations. Like by using the database management system, we are able to create a database. We are able to store the value into the database that you have created. We can update the value that is already stored in the database, or even we are able to create the tables in the database. So all these operations are performed by using the database management system. It provides protection and security to the database. By using the database, we can protect or secure the data. In the case of multiple users, it also maintains the data consistency. So this is the introduction of database management system. So it is one of the management system that is used to manage your database. You can either perform the various operations like data creation, inserting the value into the tables, updating the values that is already inserted into the table. So by using the database management system, we can ensure the protection and security of the data also. Next, DBMS allow users the following task. So first of all, we can define the data definition. It means we can create the tables, and it's completely depend upon you how many columns you want to add into your table. Data updation means once we have created the table and values are inserted into the table, and later on you want to do some changes, it is also possible with the help of data updation. Next is data retrieval. Data retrieval means we can fetch or get the data from the tables that is already created. Next is user administration. There is a one person in the DBMS that is known as DBA, database administrator. Basically, database administrator is the person that is responsible for the overall control of the database management system. So data definition, data updation, data retrieval, all these tasks is controlled by user administration. Next are the characteristics of DBMS. First is it uses digital repository that is known as data dictionary, established on the server to store and manage the information. So in this case, we have a digital record of data. We have a digital data dictionary from which we can get the data. It provides clear and logical view of process that manipulate the data. So the data that is provided in the database is error-free. DBMS contain automatic backup and recovery procedure. If we are storing the data into the DBMS, we have the options to automatically get it recovered and take its backup. It contains ACID properties. ACID stands for, A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. It contains ACID properties which maintain data in the healthy state in case of failure. If we are using the ACID properties, we are able to recover the data in the case of failures. So if we are using DBMS, we can split the complex relationship into simple ones. It used to support manipulation and processing of data. We can easily manipulate and we can easily process the data. It provides the security of the data, and it can view the database from different viewpoints according to the requirement of users. So everyone have a different view regarding database. So it should be adjustable according to the view of every user. Next, the term we have that is known as acid properties. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Now see atomicity. The term atomicity defines that the data remain atomic. It means if any operation is performed on the data, it should either complete it fully, or if you are not sure to complete it fully, don't start it. Atomicity, it means if any operation is performed on the data, either it should be performed or executed completely or should not be executed at all. It ensures the full completeness of any operation or any transaction. If you are not assured enough to complete your transaction, never start it. Second is consistency. Consistency means that value should be remain preserved always. It means once I have set the value, it should remain static, no matter how many other values we are inserting into the table, but it should be consistent. Isolation. The term isolation means separation. In DBMS, isolation is the property of database where no data should affect the other one and may occur concurrently. Let us suppose that I have 5 entries in the table, and on the next day, again, I am inserting 5 values in the table. So first 5 values should remain consistent. It should be isolated from the next 5 values. They are separated from each other. Next is durability. Durability means it ensures the permanency of something. Once we have updated the value, it should remain updated till the lifetime of that table or till the lifetime of that variable. It cannot be deleted. It cannot be changed. So these are the working of the acid property: atomicity, consistency, isolation, and durability. Next, we have advantages of DBMS. What are the various benefits of using the DBMS? First is it controls the database redundancy, means duplicacy. So if we are using the DBMS, we are able to find out the duplicate values in the tables. And if such situation arises, we are able to remove that duplicate values from the table. Next is data sharing. So if we are using the database management system, we are able to share the single table among multiple users. Easily maintenance. We can easily maintain the database that is of centralized. Next is reduce time. It helps to reduce the development time. As one table is shared among 10 people, so it reduces the time of creating the 10 tables separately. Next is backup. If we are using DBMS, we have the options to automatically get a backup of the data and recovery. Next is multiple user interface. It provides different types of user interface to the users according to their requirements. Like it provides graphical user interface, it provides application program interface. It's depend upon the requirement of the user, which type of interface he or she wants to get. Next, we have some disadvantages of using the DBMS. The first is cost of hardware and software. As we know that DBMS is the digital database management system. So we have to put more cost for hardwares and software. Next is size. It occupies the large space of disk and large memory to run them efficiently. So we need more memory for supporting the DBMS. Complexity. Sometimes it creates additional complexity and requirements. Otherwise, it is the very good database management system. Higher impact of failure. Failure is highly impacted the database because in most of the organization, all the data stored in the single database. And if that single database is damaged due to some electrical failure or any other causes arises, then we have to bear the loss of the data failure. So these are some of the disadvantages of DBMS, as it is the digital database management system. So we have to put more cost for hardware and software. We need more memory, and sometimes little bit it create additional complexities and requirement. And if we are dependent upon the single database and due to some reason that single database got crashed, damaged, we have to bear a loss for that. The next topic is DBMS architecture, database management system architecture. The basic client server architecture is used to deal with the large number of PCs, web server, database servers, and other components that are connected with network. So in DBMS, we have two terms. One is client and second is server. Client is the person that are sending the request, and server is the person that is accepting the request coming from the client, processing the request, and send the result back to the client. The client-server architecture consists of many PCs and workstations which are connected via network. So in client-server architecture, there are multiple computer systems are connected with each other. DBMS architecture depends upon how users are connected to the database to get their request done. So we have a different types of architecture. We have to choose wisely according to the requirement. Types of DBMS architecture. We have a one-tier architecture, two-tier architecture, and three-tier architecture. Select according to your requirement which architecture is best to suit you to your requirement. It may be seen as a single tier or a multi-tier. So we have a two-tier architecture, we have a three-tier architecture also. Now we are going to discuss about one-tier architecture. One tier means one level architecture. In this architecture, the database is directly available to the user. In this type of architecture, there is no middleware, there is no middleman. Simply the client is directly connected with database. It means user can directly sit on the DBMS and use it. I don't need to send the request to the central person. In one-tier architecture, as a user, we can directly send the commands to the DBMS, and after processing the instructions given by the user, DBMS directly send the result back to the user. Any change done here will directly to be done on the database itself. So there is a direct relationship between user and DBMS. The one-tier architecture is used for development of local applications. Basically, it is used for designing a simple and local applications where programmer or where user can directly communicate with the database for quick response. So one-tier architecture means it is one of the simplest form of architecture. In this architecture, we have two parties. One is user, programmer, client, and second is the DBMS. The user can directly communicate with the DBMS for any type of operations, and the DBMS send the result directly back to the users. So this is the simplest form of communication, and basically it is used when we want to get the result in a very quick manner. Next is two-tier architecture. The two-tier architecture is same as the basic client server. In the two-tier architecture, we have applications on the client end directly communicate with the database at the server side. For this interaction, we have to use some APIs, application programming interface like ODBC, Open Database Connectivity, JDBC. All these APIs are used in the type of two-tier architecture. The user interfaces and the application program are run on the client side. So in this case, we have one application program. Now in a one-tier, user can directly communicate with database. But in case of two-tier, now user first need to communicate with the application program, then application program can communicate with the DBMS or database. The server side is responsible to provide the functionalities like query processing and transaction management. So at the end of or at the side of server, what operations we have to do, basically DBMS or database is responsible for processing the queries and transaction management. To communicate with the DBMS, the client-side applications, like it may be a user, it may be a programmer, they have to establish a connection with the server side first. Now see, in this case, let us suppose if we discuss about one-tier architecture. In one-tier architecture, user can directly communicate with database system. We don't need to be dependent upon the applications. But in case of two-tier architecture, user first need to send his or her request to the application. Then application carried your request to the database system. Again, database system process your request. It cannot send the result directly back to the user. It sends its result back to the application, then application forward the result back to the user. That's why it is a two-tier. Tier 1 is client, then tier 2 is a server. So it's a two-tier. First, user send the request to the applications, application forward the request to the database management system. The database management system send the result first to the application, then application forward the result back to the user. There is no direct communication between user and database system. First, we have to both client and server, both user and database system, both are dependent upon the applications. Next, we have a three-tier architecture. The three-tier architecture contain another layer between client and server. In this architecture, client and server are not directly communicate with each other. They have to depend upon the one layer that is known as a application layer. Now see its diagram. Database have an application server, whereas a user have an application client. So user are completely dependent upon the application client. User application client forward the request to the database application server. From database application server, request will go to the database. Once the request is received by database, it is processed by database, then the result of the request is first forward to the application server, then application server forward the result back to the application client, then application client forward the result back to the user client. So in this way, tier 1, tier 2 or tier 3 architecture is working. Next heading is data independence. Data independence refers characteristics of being able to modify the schema at one level of the database system without altering, modifying or changing the schema at the next higher level. So data independence means we have three levels. So if we make change at the one level, it does not reflect back to the remaining levels of the schema. We have two types of data independence, logical data independence, and we have a physical data independence. Now there is one term that is database schema. Basically, database schema is a skeleton structure that represents the logical view of the entire database. Database schema represents the structure and the design of the schema. That is structure and the design of the table, how it is looking, how many fields we have in the table, what are the various constraints that we applied on the data, what are the relationship among the values in the table. All these should be reflected with the help of database schema. Database schema defines what are the various entities in the table and what is the relationship among all these entities. It contains the descriptive detail of the database. How many constraints we have in the table, how many keys we are using in the table. It means it defines the blank or it defines the structure of the table. That is known as database schema. It defines the logical view of entire database, how it looks, how many entities it have, what is the relationship between the entities, how many types of keys we are using. All these should be defined by the term that is known as database schema. Now see, we have a stored database. Then we have a internal schema. Internal schema means this represent the physical level. That is the lowest level. Then there is a bidirectional communication between conceptual schema. That is one level higher to the physical level. Then we have a external schema that is very close to the external user or that is very close to the end user. Now we are discussing about data independency. It means that if we do any change in the external level, it does not reflect back to the conceptual level or physical level. If I do any change in the physical level, it does not reflect back to the conceptual level or external level. Every level is independent among each other. Now, next we have a logical data independence. Logical data independence means, logical means we are structure. So if we are performing any changes to the structure of the database, it does not reflect back to the other levels of database. So logical data independence refer characteristics of being able to change the conceptual schema without having to change the external schema. It means if I'm going to change the conceptual schema, I don't need to change any external schema. All both are independent of each other. Logical data independence is used to separate the external level from conceptual level. So if we are working about the logical data independence, it means external level is completely different from conceptual level. Logical data independence occur at the user interface level. So it defines the ability to make changes in the structure of the middle level of the database management system. Now see, if I want to perform the change in the logical, it does not reflect back to the conceptual, it does not reflect back to the physical level. Every level of DBMS is independent of each other. For example, the addition or removal of new entities. If I'm going to add some new entities into the table, if I'm going to delete some values or entities from the table, if I'm going to add or remove some attributes or relationship to the conceptual schema, it does not reflect to the any other schema of the table. Next, we have a physical data independence. If I'm going to change the internal structure of schema, it does not reflect back to the conceptual schema. It does not reflect back to the other schema. Let us suppose that I'm going to make some changes over there. I just want to do some little change in the internal schema. It does not reflect back to the conceptual schema. It does not reflect back to the external schema. Both remain static. For example, a change to the internal schema, such as using different file organization, or I'm going to change storage structure, storage devices, they don't have any change to the conceptual or external schema. Ultimately, the working of data independence is that if we are going to make some changes in the logical data, it does not reflect back to the conceptual or external data. If I am going to make some changes on the physical level, it is completely separated, isolated from the conceptual or external level. Any change made to any one level does not have any impact on the other levels. All the levels are independent of each other. The next is structure of database management system. So database management system, that is known as DBMS, it is the software that allows access to the data stored in the database and provide an easy and effective method of. So DBMS is the system that we use to manage the database, but it provides some easy and effective methods so that we can define the information by using the database management system. We can store the information by using the DBMS. Even we can manipulate. Manipulate means we can update the value that is already stored into the tables. So it protects the data and it gives different permissions according to the different requirements of the user. So first, by using the DBMS, we can create the table. We can store the value into the table. We can update the values that is stored into the tables. We can protect the tables, or we can provide different permissions to the different people according to the requirement. The database system is divided into mainly three components: query processors, storage manager, and disk storage. So query processor is basically used to manage all the queries. I just want to create a table. Let us suppose you want to create a table. For a table creation, delete a table, update command, select command, for various types of commands, for various types of queries. All the queries are managed by query processors. Storage is managed by storage manager, and disk is managed by disk storage. Now we have our DBA. DBA stands for database administrator. It is one of the person that is responsible for controlling the entire database. We have our users, then we have our application programs. So DBA have our database schema, then DBA have our data definition language compilers. So this is this portion, this dashed lines represent DBMS. And the last we have a text, and text we have a data files plus data dictionary. Data dictionary means data repository, means it contains the entire detail of the table, name of the table, size of the table, constraints on the table, full detail of the table is recorded in the data dictionary. So DBMS have data dictionary manager, query optimizer that is responsible for managing your various queries. I want to create, update, delete, insert. We have a scheduler for scheduling the commands. We have a recovery manager to recover your data in the case of failure. We have a authorization control that deals with the users, means to whom we have to give permission to access the tables. We have a command processor that process your various commands. It is the DML command, DCL command, TCL commands. We have a transaction manager to manage all the transactions. Then we have a buffer manager. And we know that buffer is the temporary working area. So its management is done by buffer manager. And we have an integrator checker that is used to ensure the integrity, that is used to ensure the correctness of your database. In DBA, we have a database schema and DDL compilers. In case of user provide queries and these queries are processed by query processors. In case of application programs, we have application program, then we have a DML compiler. So this is how the DBA users, application programmer are connected with each other. Now we have a query processor. Query processor is responsible for processing the DML queries, DCL queries, TCL queries. It has DML compiler that is used to manage the various DML languages. DML stands for data manipulation language. It has, I think, select, insert, delete, update. Then we have a DDL command interpreter, data definition language, that is of having create. Then we have a rename, truncate, drop. Embedded DML pre-compiler. Basically, it processes your DML statements that is embedded into the application program. Last, we have a query optimizer. It executes the instructions that is basically generated by DML compiler. So query processor is only responsible to process all the queries. It may be a DML, DDL, TCL, whatever the query you want to process. Next, we have a storage manager. It is responsible for maintaining the storage. So in this, we have an authorization manager that is used to control the security of the table. Let us suppose that first we have to provide the user ID and application ID or password to everyone. So if he or she have a correct user ID and password, then he or she are authorized or allowed to access the tables. Then we have an integrity manager that ensure the correctness of the database. Then we have a transaction manager. It controls the concurrent access by performing the operations in the scheduled way, that is, it receives the transaction. Basically, all the transactions that are running inside the DBMS is controlled by transaction manager. Next, we have a file manager that is used to control the entire file working of the database. Then we have a buffer manager. It is responsible for cache memory and the transfer of data between secondary storage and main memory. Next, we have a disk storage. Basically, we have a data files. In this, we have to store the data. Then we have a data dictionary. So data dictionary is also known as a metadata or a digital data repository that contain the entire information about the tables. Then we have indexes. It provides the fast retrieval of record. If let us suppose if we don't have an index in the front of the book, we are not able to find out the correct chapter. So by looking at the chapter number and according to the page number, we can easily find out the chapter. In the same way, if we have an index, if we are using the index, it provides fast retrieval of data item. So that is the structure. First, we have a query processor, storage manager, and next we have a disk storage.